Alright, we are in unit number 2. We're on page 6 of your notes, class demonstration, speed trap. We're not gonna. This is kind of tough to do on a video, so I'm not going to spend a lot of time on this. This is going to be a short video, but I'll just tell you a little bit about what we did in class. We went out to the road that's right next to the high school, which is Alpine, and so maybe here's LHS. Here's the school, and here's the driveway, and here's the stoplight. Here's the nursing home that sits across from the high school. And basically, we took cars. There's a big, long sidewalk that goes right across from the high school. It's right here. And we wanted to determine the speed of cars that were traveling along Alpine, and then actually post their speed form. To actually communicate in some fashion or in some way to that driver how quickly he or she's driving along the road. And so what we did was we had actually 3 groups. We had a group that sat right out here, a group that sat right out here, and then a group that kind of sat right here. And when the car passed this group, they dropped their hand. It's kind of like motion that the car passed. This group over here, when they saw this hand drop, they actually started the stopwatch. When the car got to this point, they stopped the stopwatch. They took that time, plugged it into the calculator. So here's D equals V equals D over T. So they already had the distance. We knew this distance. I think we usually use right around 100 feet or so. So we knew 100 feet was in there already. And then we divided by, it should be time. We divided by time. And then that gave us our speed. And then what we would do is we would radio down to another group that had a big sign, like a whiteboard sign, and they would write right on that sign how fast they were going. So they would say like 50 miles per hour, and they would hold it up for that driver to be able to see how fast they're going. All right. Well, as we worked through this, we found that it's best that if we make this interval right here as small as possible. So we actually want that interval to shrink. Now, as it shrinks, we'll have to remeasure the distance, obviously. But we wanted that interval to be short, and the reason for that is if the interval is long, then it gives time for this driver to change his speed inside that interval. And if he changes the speed of his car as he's driving, then the speed that we calculate won't be necessarily the speed that he's actually driving. Ideally, we would like this interval to actually approach 0. It can be really, really, really close to 0. Because if it's really close to 0, then that driver basically has no time to change his speed. And so whatever speed we calculate is going to be the speed of that car. There's a device that's inside your car that actually does that for us, and that's your speedometer. And your speedometer actually calculates your instantaneous speed. So we'll run through the definition of instantaneous speed, and then we'll wrap this video up. So instantaneous speed, this is the speed of an object at a particular instant in time. And the only way that you can get that is to make that time be really, really, really small. And what device in your car measures your car's instantaneous speed? And that would be the speedometer.